Python is very crucial for any aspiring data professional. In this new course called Intermediate Python, we'll learn all about the Matplotlib functions and get familiar with data structures such as dictionaries, pandas, data frames. So welcome back to the channel and welcome to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. Today is day 6. So we've been learning consistently over the past 5 days. So on day first, which was day one, the first day, we started this whole learning journey a couple of 4 live stream or 5 live streams ago. So on day one, we learned all about variables and data types in Python. On day two, we went further to create how to create lists in Python. We learned all about manipulation of lists, adding, removing, replacing lists. So on day three, we got introduced to functions and packages in Python. On day four, we launched or we imported our first package, which is the NumPy package, and we learned all about working with the NumPy, how to work with the NumPy package actually. So on day five, we completed the NumPy package learning journey, which we had to complete on day five. So on day six, so today's day six, then we'll be starting a new course entirely. So on day 1 to 5, we actually focus on introduction to Python, basically then. So you can catch those lessons, those live stream on the live stream tab on the channel if you're looking towards to get started with Python. So today we'll be moving to a new course, and this course actually contains 5 chapters. So the first one we'll be looking at is the first chapter is all about the matplotlib function, which is a great meaningful Python package for data visualization in Python. We'll be learning how to create and make meaningful, insightful plots with the matplotlib package. Also in this course, this intermediate course in Python, is the dictionaries and pattern. You learn how to work with dictionary and pandas, a logic, control flow, and filtering. Then the chapter 4 is all about loops. Then finally, we're going to round it up with a case study, which is the ACA statistics case study using Python to analyze the data set. So welcome back to the channel. Also, all data sets, exercise files, Python files, CSV files that we're connecting to in Python will be linked under the YouTube description. So do make sure to download those files and practice along or with me. So without further ado, let's jump back to learning and welcome to day 6. Do well to support the channel by giving this video a thumbs up, this live stream a thumbs up whenever you come across it. Hit that subscribe button and put on the notification bell so you'll be the first to know whenever I go live or start a new learning journey or drop a new content on the channel. So let's jump back to our Python learning journey. So I go to my DataCamp interface really quick here. So you can see if I go under the career tag section, just real quick. So it all started with the data analysis in SQL, which went for a period of 100 days. We also did the data analysis in Power BI. We completed the whole learning challenge on probably 69 or 60 something days of learning. We also completed this. So we're looking to create more portfolios, and I'll be sharing all those with you in on the channel. So look out for the portfolios on SQL, the challenge, the projects on SQL and Power BI that I'll be sharing with you pretty soon. So let's move to data analysis with Python real quick and see what we have here. We have 36 hours of learning and 9 courses, 2 skills assessments on 5 projects. I think this is one of the best course on the DataCamp platform with more projects that I've taken so far. The SQL challenge has like 2 or 3 projects. The Power BI or course has the career track has like 2 projects. While this Python analysis, data analysis with Python has 5 projects, I think so. So we are continuing with or starting with intermediate Python. So I'll just go to the Matplotlib section real quick. Let's click on the Matplotlib section and start from basics of Matplotlibs. So we want to get introduced to the basics of Matplotlibs real quick. So while that is coming up, I've launched my Nakoda Navigator. I'll just launch my Jupyter notebook real quick. So I've shown you how to install and download the Jupyter notebook. Sorry, this Anaconda Navigator that will give you access to Jupyter Notebook and all the Python environment that you need or to start coding in Python. So that is launched down already. I'll just minimize this. Then we continue from here. Just a second there.
Hi, my name is Hugo, and I'm a data scientist and educator at DataCamp. I'm also the host of the weekly podcast Data Framed, which you need to check out to stay up to date with everything that's happening in data science. In this intermediate Python course, you're going to take your Python skills to the next level, specifically for data science. You'll learn how to visualize data and how to store data in new data structures. Along the way, you'll master control structures, which you'll need to customize the flow of your scripts and algorithms. These are the types of things data scientists use every day. We'll finish this course with a case study where you'll blend together everything you've learned to solve an exciting challenge. This first chapter is about data visualization, which is a very important part of data analysis. First of all, you'll use it to explore your dataset. The better you understand your data, the better you'll be able to extract insights. And once you've found those insights, again, you'll need visualization to be able to share your valuable insights with other people. As an example, have a look at this beautiful plot. It's made by the late, the great, Swedish professor Hans Rosling. His talks about global development have been viewed millions of times. And what makes them so intriguing is that by making beautiful plots, he allows the data to tell their own story. Here we see a bubble chart, where each bubble represents a country. The bigger the bubble, the bigger the country's population. So the two biggest bubbles here are China and India. There are two axes. The horizontal axis shows the GDP per capita in US dollars. The vertical axis shows life expectancy. We clearly see that people live longer in countries with a higher GDP per capita. Still, there is a huge difference in life expectancy between countries on the same income level. Now, why am I telling you this? Well, because by the end of this chapter, you'll be able to build this beautiful plot yourself. There are many visualization packages in Python, but the mother of them all is Matplotlib. You'll need its subpackage pyplot. By convention, this subpackage is imported as PLT, like this. For our first example, let's try to gain some insights in the evolution of the world population. I have a list with years here, year, and a list with corresponding populations, expressed in billions, pop. In the year 1970, for example, 3.7 billion people lived on planet Earth. To plot this data as a line chart, we call plt.plot and use our two lists as arguments. The first argument corresponds to the horizontal axis, and the second one to the vertical axis. You might think that a plot will pop up right now, but we actually need to call the show function to display the plot. This is because you might want to add some extra ingredients to your plot before actually displaying it, such as titles and label customizations. I'll talk about that some more later on. Just remember this. The plot function tells Python what to plot and how to plot it. Show actually displays the plot. When we look at our plot, we see that the years are indeed shown on the horizontal axis and the populations on the vertical axis. There are 4 data points, and Python draws a line between them. In 1950, the world population was around 2.5 billion. In 2010, it was around 7 billion. So the world population has almost tripled in 60 years. What if the population keeps on growing like that? Will the world become overpopulated? You'll find out in the exercises. But let me first introduce you to another type of plot, the scatter plot. To create it, we can start from the code from before. This time though, you change the plot function to scatter. The resulting scatter plot simply plots all the individual data points. Python doesn't connect the dots with a line. For many applications, the scatter plot is often a better choice than the line plot. So remember this scatter function well. You could also say that this is a more honest way of plotting your data, because you can clearly see that the plot is based on just 4 data points. Now that we've got the basics of Matplotlib covered, it's your turn to build some awesome plots. Have fun, but make sure to come back so we can plot even more together.
Interesting. I think the two most important thing we focus on here are the scatter plot and the line plots in Matplotlibs. So it said line plus one. So it says with Matplotlib, you can create a bunch of different plots in Python. So the most basic plot is the line plot. The general recipe is given here. So I'm going to import Matplotlibs package and the pyplot subpackage as PLT. So whenever you want to call on the pyplot package, we're just going to use the shortcut key or keyword PLT in this case. If it plots x-axis, x variable and y variable, you're going to use the plt.show to visualize the x and y variable that you've plotted. That's quite interesting. So in this video, you already saw how much the world population has grown over past years over the past years. So we need to continue to do so. So the World Bank has estimates of the world population for the years 1950 up to 2000, 2100 rather. So the years are loaded in your workspace as a list called year. So, and the corresponding population is a list called pop. So this course touches a lot of concepts you may have forgotten. So if you ever need a quick refresher, download the Python cheat sheet here and keep it handy. So we have the Python cheat sheet already, just in case we need to look up some stuff. So the Python cheat sheet is quite interesting. If I open that in a new page, you can see how awesome the cheat sheet is. If you want me to link the cheat sheets as part of the resources in the file, under the YouTube link, do drop it in the comment for me. Then I'll link this cheat sheet for you so you can have access to it also. So if you continue reading the instructions, that says print the last item for both the year and the pop list. So for both the year and the population list to see what the predicted population for the year 2100 is. So use two print function here. So we're going to use the print year minus one. Since the year is just a single column, since we want to see the last item in that column, we're going to use minus one. So it's going to start from the last row and show us the record in that last row there. So also same thing with the pop column, the pop data frame, the pop data structure, just a single column. If I use minus one, index minus one, it will be returning the record from the last row. So for that, before you can start, you should import the matplotlibs.pyplot as PLT. So pyplot is a subpackage of matplotlib package. So hence the dots. So we imported the pyplots package here. So it now says use the PLT plot to build a line plot here. So we built a line plot here and be mapped on the horizontal axis while the population on the vertical axis. So the year is going to be on the horizontal axis while the population is going to be on the vertical axis. Then we use the plt.show function to actually display the plots. If I run the code now, it should run successfully. Hold up. Oh, I'm selecting pop here. I actually selected pop here. It's going to run the population column for me. You can see. So when I selected, let me select the year also here. See the year record here. I see how long the year record is. You could see that here. Okay, the year should be here. I see the year record here also. If you take a sneak peek, so we'll be seeing 2100 as the last record in the year. Then we should be seeing the 10.85 billion as the population for that year. Let's run the whole code right here now. You can see 2100 as the last record, then 10.85 as population for the year 2100. So that's quite interesting and straightforward. Let's submit our code right now. So it now says it's a line plot to interpretation. Let's try to interpret the line plot that we've created. It says have another look at the plot you created in the previous exercise. It is shown on the right. Based on the plots, in approximately what year will there be more than 10 billion human beings on the planet? So we look at more the records, we start going the year where we start having 10 billion people. So right from here. So from 2060, the year population will start going over 10 billion. So the reason why we chose 10 billion here. You can see that it says, so time to take your data visualization skills to the next level. Interesting. Now, line plot 3. Now that you have built your first line plots, so we built the first line plots. Let's start working on the data. So the data that we're actually going to be using here is the Hans Rosling that the professor Hans Rosling used to build his beautiful bubble chart. It was collected in 2007. Two lists are available for you, which is the life expectancy, which contains the life expectancy for each country, and the GDP per capita, which contains the GDP per capita, per person for each country expressed in US dollars. So GDP stands for gross domestic product. It's basically represents the size of the economy of a country divide this by the population, and you get the GDP per capita. So that's quite interesting. So we're going to use the Matplotlib function. Package is already imported as PLT, so you can get started straight away. So I'm going to access this data set within my Anaconda, the Python package here, my Jupyter notebook file here. I just go to my download file real quick. So under the Python, my Python list. If I go to my intermediate my data set file, my intermediate. So I have the file here. This is this Gapminder CSV file here, which I'm going to be linking under the YouTube description so you can download. So I have my Python file, my Jupyter notebook file already created here. You could see, let me just show you what it looked like real quick. So we have the data sets here, this Gapminder data sets. So if I already call on the data sets, I imported NumPy as speedy. I'm going to be using NumPy to manipulate my data a little bit, and the pandas to access to read the file. If I run the pandas data frame here, if I run it, because I have access to the column here. Okay, let me just run the PD again. So then I run this code again. You can see now. So this is my data sets here. We have our GDP, life expectancy, and GDP per capita for the you can see the year is 2007. The data was collected in the year 2007 according to our variable here. So we have access to the data set already here. So we've called on the data sets. If I click on the get gapminder.head, I'm going to see the first 5 words, the first 5 rows. So from this place, I'm going to be manipulating the data so we can also practice or what we'll be practicing here. We can actually practice them in the Jupyter Notebook environment here also. So let's go ahead with that. So it now says print the last item for both the list GDP per capita and the list life expectancy. It is information about Zimbabwe. Let's print the last item. So build a line chart. So the first instruction, print the last item of the GDP per capita column and the life expectancy per capita column. So if I click on print, if I write the print function real quick here, print, open and close brackets, since the last item from that list, so I'm going to be using -1 also. So -1, so I have to call on the GDP first. Which one is the first column here? Life expectancy and GDP. Probably the life expectancy is the first column. So let's call on GDP. Then I'm going to use the index notation -1 to call on the last item there. Then I'm going to be doing the same thing for this. So it's going to be life expectancy this time around. So that should show. If I just select these two codes, if I select these two codes, let's run it and see. You can see. So these are the last two items for this DTP per capita and the life expectancy. So also in my Jupyter notebook here, I actually converted this data, this column of data into an array. I converted it into an array. Since we have many columns there, the only challenge here is that we actually have access to pretty columns here, more than, let me see, we have 7 columns here. But what I actually need is the last 2 columns. I'm going to create a new variable called life expectancy. So I'm going to call on the life expectancy and point to the data set, the last second to the last column on this Gapminder data set there. So it should return this data frame for me here, this array of column here. So that's what we have here. Life expectancy is returning what? The last column, the second to the last column of life expectancy. You can see 43.828, 76.423. If I look at my life expectancy array here, you can see 43.287%. This is our own. This is the data set that we have here. So same time, I'm going to do the same thing for the GDP per capital. I'm going to say gap minder data that I converted into an array. I'm going to use this one means it should return all the rows of record in that column. It should return the last column for me here, which is what it is actually doing here. Returning the last column, this GDP column from my gap minder data sets. So with that now, I can also return the last record here. I'm just going to copy this data, this print here. Print the last item. I'm just going to copy this code here real quick. If I copy the code there, let me now paste it here. Since I use almost the same thing, I use GDP underscore, you can see GDP underscore cap. My life expectancy is live underscore ESP. Let's see. Let me run the code and see. Ooh, GDP is not defined. Okay, let me just go back and run my code again. Okay, from here, from here, from here, from there, from there, from there. I just need to rerun the code. Voila, you can see now my code worked perfectly well. So if I compare this record here with the actual record from the data, so you can see the 469.7 and 43.487. So that's how we could access. You can see 469.7 decimal places and 43.487. You can see 43.487. So that's how we can access the so if you actually need a particular column from a whole bunch of columns, you can use this DTP, convert the column to an array, and use the NumPy package to do that easily. That's interesting to see. So now let's move on to the next instruction. Next instruction now say make a line plot with GDP cap on the x-axis, life expectancy on the y-axis. So let's make a line plot. So our first is going to be a line plot. So it's going to be plots. I'm going to say plt dot plots, open bracket. So my GDP is going to be on the x-axis. The x-axis is going to be the GDP. I'll just copy this GDP real quick here. So my y-axis is going to be life expectancy. Let's see what it looks like. Life expectancy. So display the plot. So plt dot show. Now let's see what we have here. Let's run the code. Ooh, interesting. This looks really. Let's submit the code first and see. Ooh. Now let me now look at the plot where we say GDP on the x-axis, life expectancy on the y-axis. Ooh, this look really funny though. Let's submit and see first. Well done, but this doesn't look right. Exactly, doesn't look right though. But let's just do the same thing here. I'm going to recreate same the chart. Definitely, line plot doesn't actually fit the data set. Let's run it and see here also. Ooh, oh, PLT is not defined. Oh, okay. I've not imported Matplotlib. So I need to import Matplotlib here. So I need to go back to the top of my data sets here where I want to be importing the whole package. Okay, let me just go back up. Let me just copy this real quick. So I've not imported the Matplotlib package in this instance here. I'm going to say import Matplotlib. Let me import Matplotlib as PLT. You can see, so I could just go down there and see. So consider we have same results here. Pretty interesting, right? Since we've imported the Matplotlib as PLC all the way in my package here, if I should run the code actually from here, you see, so make a line plot on the x-axis and life expectancy on the y-axis, plot, GDP cap, life expectancy, then display the plot, you can see. So this is exactly what we have here in our Jupyter notebook. Is exactly what it is showing here. Let's see how we can use the scatter plot to make this much more better. Well done, but this doesn't look right. Let's build a plot that makes more sense. Exactly. So let's build a plot that actually makes more sense. So scatter plot 1. I see scatter plot 1 and scatter plot 2. Interesting. Now let's see. So when you have a time scale along the horizontal axis, so the line plot is your friend. But in many other cases, when you are trying to assess if there is a correlation between two variables, for example, the scatter plot is the better choice. So okay, when you have a line, a time scale so because we don't have a time, so a line plot is usually used for time series analysis. So and this is not a time series analysis, so it will really make sense. So but in many other cases, when you are trying to assess if there's a correlation between two variables, so whenever you want to see if there's a correlation between two variables, so scatter plot is the better or chart or the better plot for that. So below is an example of how to build a scatter plot. So I'm going to import matplotlib as pyplot as plt as usual. Instead of saying plt.plot, which is going to show a line chart, we're going to say plt.scatter. So let's continue with the DDP versus life expectancy plot. So the GDP and life expectancy data for different countries in 2007, maybe a scatter plot will be a better alternative. Again, the Matplotlib PyPlot package is available as PLT. So put the axis on the logarithmic scale. How do we do that? Let's see. So change the line plot that is coded in the script to a scatter plot. Okay, we want to change this to scatter, just as easy as that. So I'm going to call on scatter there. Pretty straightforward, right? So since we've done that, so a correlation will become clear when you display the GDP per capita on a logarithmic scale. Add the line plt.scale, open bracket, then hashtag log. So let's add this line of code here. So this converts this to what? To a logarithmic scale. Okay. So the x-axis actually probably the GDP scale is going to be converted to a logarithmic scale. So a correlation will become clear when you display the GDP per capita on a logarithmic scale. Okay, this is what we are doing here. We are converting the x-axis, which is the GDP per capita, to a logarithmic scale. So I'm going to say plt.show now. plt.show. So this should display our results correctly now. Ooh, nice one. I think this is much more better and interesting. So I'm just going to copy this same code here. I'm just going to paste it on my Jupyter notebook. Now let's see what we are going to have there. Now let's see this in action. So you could see, so change the scatter plot. We want to plot scatter plots. So since we plot that, I'm just going to run this code. Voila. This is much more better, you can see. This is much more better and interesting to see. You can see all our country and there are dots. So these are just the countries and the dots. If I go back to the data plots, you can see the country and their life expectancy versus their GDP per capita. This is what we're actually visualizing from this data set here. This is what we are seeing. So on a line chart, it is not communicating any insights. On a scatter plot, we are getting a little bit closer. So you can see the dots are still almost the same thing. But if you start adding more bubbles or more sizes to it, we're going to differentiate between the dot. But mainly looking at it, the more packed they are, the higher the correlation. So let's get to that stage. I'm just using my Excel knowledge in this instance here. Now let's submit the code. Okay, that looks much better. Exactly. Let's continue. So scatter plot too. So in the previous exercise, you saw that the higher the GDP usually corresponds to a higher life expectancy. Exactly, you can see. Now we look at the plot. Let me see. Look at the GDP on the x-axis. So they are the GDP. They are the GDP. You can see. They are the GDP. They are the what? The life expectancy of the population in that country. Interesting. Now, do you think there is a relationship between population and life expectancy of a country? So the list life expectancy from the previous exercise is already available. In addition, now also population is available. So listing the corresponding population for the country in 2007, the population are in millions of people. So we're going to import the package, build a scatter plot, show scatter plot. So start from the scratch, import matplotlib.pyplot as PLT. I'm just going to say import the pyplot package from Matplotlib again. Now, build a scatter plot where pop is mapped on the horizontal axis and life expectancy is mapped on the vertical axis. So finish the script with plt.show to actually display the plot. Do you see a correlation? So I'm going to now go back to my data set here and also call on the population column for my array. You can see the population column is this fourth column -1, -2, -3, -4. The fourth column actually here is the population axis. So this is what I did here. I converted my gapminder data into an array using the numpy package to convert it to an array. So I could access specific column from the what? From the O column here. So I'm going to go back here and say pop. Let me go back here and say pop. I'm going to copy this code and use it also again. Let me just add a new cell below here. So the new cell is going to be pop, pop, then -4. So actually access the what? The fourth column here. -1, -2, -3, -4. That should give me the what? Access to the fourth column there. Where is that? -4 here. So I'm going to add a new code below. So if I call on pop now, I should see those data sets. You can see this is the population. So I can actually use this population to visualize my data set also. Interesting. You can see that. So we're actually here though. So since I've imported Matplotlib already, all the way from here, my package already imported from the beginning of my code there. So I can actually use them for my analysis there. Now let's see. So build a scatter plot. Want to build a scatter plot? Let me just copy code here real quick. So build a scatter plot. I'm going to say plt.scatter. Where's scatter here? I just copy this plt.scatter real quick. So now I want the what? Build a scatter plot where pop is mapped on the horizontal axis. So pop is on the horizontal axis, while life expectancy is on the vertical axis. So pop first here, pop and life expectancy also here. So plt.show, plt.show for us to view the data set here real quick. Let's run the code. Oh, I'm missing it. Pop on the horizontal axis, life expectancy, okay, it's the way around, the other way around. Sorry about that. Now let's see it again. Ooh, let's submit and see. Oh, check your call. Oh, I'm missing it up. Horizontal and vertical. It gets confusing at times. Mm. Okay, now let's run the code again. Oh, so you can see. So this is what we needed to return actually. So nice. There's no clear relationship between population and life expectancy, which makes perfect sense. What I'm going to do now is to copy this line of code also and just use it to build same analysis on my Jupyter notebook here. So I'm just going to copy it here. I want to build a scatter plot using pop. This is our population here. This pop record here. And let's see that in action. As you can see that we have same record, the same instruction here, same result rather. And then there's no correlation here. You can see they're all just parked to the left hand side, and it doesn't really, it's not giving much insight as we can see from here that there's nice. There's no clear relationship between population and life expectancy, which makes perfect sense. You get it now? That's quite interesting to see though. So we plotted this life expectancy versus the GDP. We have plotted our population versus life expectancy to see if there's any correlation between these two variables. That's it, these two columns in the data set. So that's how easy it is to plot to start gaining insight from my data set. So the rest, I think the other thing we could do is just to add row labels, axis labels, then follow our chart and make it more interesting and more visible to the eye. I think that's quite interesting to also see. And let's continue though and see what we also have here. For histogram, we have the next chart we can build is histogram. I want to see if this will not be too much information for this live stream. If we could just stop here and continue from day 7. I see this is saying histogram. Our first histogram, with the second histogram using bins also. Compare our histogram, choosing the right plots, choose the right plot too. Then we move to customization, which has the labels, ticks, sizes, colors, additional customization, and interpretation. That's quite interesting. But I think we should stop here today just to make sure this is not too much of information in one uh in one live stream. Okay, okay. Okay, so to do a quick recap, real quick, before we end the live stream. So that's a quick recap. So it all started from when we imported just few packages. We talk about our NumPy package. We talk about the Matplotlib package. We actually haven't learned all about pandas in this section, but I just use the pandas package to access my data sets from my what? From my local machine here. Then after we imported data sets, we use the numpy package to actually turn the data sets, uh, the CSV file into an array. This is what we did here. We converted the CSV file into an array. From there, we were able to access, we made variables out of the array and access a particular column that we needed for our analysis. Then we also, that means we access the gap GDP expectancy column, the life expectancy column, the population column for this our analysis. And from there, we started plotting our variables together using those two columns. You could see the first one was we used the line charts to visualize the GDP per capita and the life expectancy, and we're getting a wrong word, the wrong visual. So line chart is not the right chart to use for those two variables. Then we also moved to using on the scatter plot, which gave a much more interesting visualization. Then finally, we use the scatter plot also to visualize the population per capita. These are the two variables, and we understood that what the GDP per capita and the GDP per capita actually and life expectancies are actually there's correlation between the two variables, while the population and life expectancy there's no any correlation with these two variables. So this is where we're going to stop on today's live stream. Then we continue from here on day 7, which we are going to be moving to histogram. So you have to plot an histogram chart. Then finally the customization of these charts. We're also talking about customization, adding labels, sticks, sizes, colors, and so on. All right, so thanks for staying to the end of the live stream. So if you found value in this learning journey with me, do well to support the channel by giving the video a thumbs up, hit that subscribe button, and put on the notification bell so you'll be the first to know whenever I go live or drop a new content on the channel. So we don't want the live stream to be too much or too long. That's why we have to cut it short on each section. So we don't want to exceed the 1 hour mark. We are just 45 minutes into the whole live stream. So we've covered how to import the Matplotlib or package and how to use it to visualize certain columns or certain variables in your data set, depending on how many columns you have for your analysis. So, and I'll see you tomorrow, day 7, as we complete the whole on Matplotlib, this chapter 1 of this section on data visualization with Matplotlib package in Python. Do have a wonderful day. Do well to support the channel. Hit that subscribe button right now and put on the notification bell so you'll be the first to know whenever I go live or drop a new content on the channel.